Okay, I just want to do a quick video about post-processing VTK files in paraview. So I've just loaded a VTK file in, and it's from UFOCFD octree version. So this particular file is about 5 million cells. So this is what we've got. It's a cube, a large cube. First thing I'd normally do is just take a slice through it just to check what's on the inside. So when we do that, we've got density, distance field, level. Whenever you select an option, you have to reset it to get the full range. So you can see here we've got levels 4 up to 11 of this aircraft geometry in the middle. So yeah, I can look at the flow solution quite quickly by this method. So it's 100 meters a second. So I can have a look at density. It's compressible flow solution, or pressure, reset, and so on. But I don't just want to look at that. I want to look at the surface. So let's delete that. First thing I need to do is point data to cell data. That's needed if I want to plot contour surfaces or iso surfaces and streamlines. So now I can select contour, and I want the contour of the distance field. So I'll select DST and set the distance field to 0. So then it is going to take a while to recalculate the distance field. So yeah, this mesh is about 5 million cells, so there's a fair bit of calculation needed there. But once we've got the distance field, then we can go and have a look at some streamlines as well, when that option becomes available. So now what we're actually looking at is the 0 level surface, or the distance field equal to 0. So we've created an iso surface of the distance field at 0. And so that is going to be very similar to the STL file, but slightly smoother. So you don't need to load in the original geometry because it's already contained within the VTK file. So having done that, we can look at, for example, the velocity on the surface. So you might expect the surface velocity to be 0, but in this immersed boundary method, I've specified the velocity to be tangential to the surface. So in other words, it's not applying a wall function as such, it's just specifying a tangential velocity at the surface. So that is what that looks like, which is great. And the next thing to do is to specify some streamlines. So we've got some streamlines there. So that needs to be done off of the cell data to point data result. So if you just load the VTK file and then press streamlines, I don't think it'll work. So this is a point source. I've got 100 there. I'm just going to change the location to -4. Change the radius to 0.2. And most importantly, go to advanced settings and change to interpolate with cell locator. because of the type of octree mesh that I'm using. It needs to be on cell locator to get continuous streamlines. So that is having a good think about that. So that's what we've got. Streamlines. So that, I mean, you can move this point around to wherever you're interested in. I would normally say have a slightly wider area, say like 0.4 for example, and also change the number of points to 100. So that'll take a few moments to calculate that. But I mean, this flow solution took only, well, less than 5 minutes to generate because I ran it on a GPU. And then once you've downloaded the VTK file, then you can see how quick it is to look at the flow solution. So, you know, for this type of analysis, you can get results really quickly. So you can be looking at a flow solution within 10 minutes, really, quite easily. And so that is a quick demonstration of post-processing VTK files in paraview.